The Big Bang Theory is a hypothesized scenario stating that all the matter and energy in the galaxy was originally compacted into a small volume until a sudden event prompted a combustion which dispersed all the compacted matter and energy, spreading it in every direction of the universe. Upon dispersion, bits of matter clumped onto one another, which eventually started forming the first galaxies. Remnants of the Big Bang are still visible today as cosmic background radiation, and ever since the Big Bang, the universe has been expanding at an exponential rate. The evidence supporting the Big Bang Theory includes light spectra, the motion of distant galaxies, and the composition of matter in the universe.
Scientists can use the light given off by an entire galaxy by picking up their frequencies through radio waves to create a spectrum that defines the distance between galaxies and the Earth. In the late 1920s, an astronomer named Edwin Hubble discovered galaxies that were shifted toward the red end of the galaxy spectrum, known as redshifts. Most distant galaxies show greatest redshift and is moving away relative to the Earth. The universe is still expanding, thus explaining the cause of redshifts.
The gauge retreat speed of a distant galaxy relative to Earth, of the actual galactic galaxy, is proportional to the distance. That is, the further the distance, the higher the velocity r. This speed-distance relationship was discovered in 1929 by the American astronomer Hubble, known as Huble's law or Huble's effect. Because it is based on the scale of the universe, the time factor cannot be ignored. The further the distance means the earlier the time. So, can it say that the gauge of the extragalactic galaxy is inversely proportional to the time? That is, the earlier the time is, the bigger the velocity r. Hubble's law reveals that the universe is expanding. The expansion is a uniform expansion of the entire space. Therefore, observers at any point will see exactly the same expansion. For many galaxies, all galaxies spread out from all sides, and the further away the galaxies spread apart, then the galaxy will stay away from us. That is, will the universe continue to spill? According to the existing doctrine, the theory that the universe will infinitely expand is the most likely and most supportive. That is, long after the distance between planets and even galaxies is far from being difficult to observe, even if light is difficult to reach, then eventually the planet and galaxy will come to an end, and the black hole will be the last watchman in the universe. Of course, human civilization probably won't last until that time.
Much of the universe is made of matter that we cannot properly detect at the moment. The matter that is familiar to humanity, including living beings, planets, and the stars, only makes up 4% of the entire universe. The rest of it is a mixture of dark matter and dark energy, which are both types of matter that are not completely understood yet. 23% of the matter in the universe is called dark matter, which lacks light but has a noticeable force of gravity. 73% of matter left over in the galaxy is made up of dark energy, which seems to manifest a force that opposes gravity. Therefore, dark energy is thought to be a catalyst in pushing the galaxies further apart. It is the overwhelming abundance of dark energy in the universe that accelerates the universe's expansion.